So I think when it comes to the spark for the big questions, those questions are the ones that bring in the brightest minds into science and technology. So in my personal experience, it's the big questions about the universe, the nature of space-time, are there multiverses? How do we combine the fundamental laws of quantum mechanics that govern material on the tiniest scales that we know in nature with the largest scales that are governed by gravity? We don't actually know how to combine the laws of physics yet. There's probably yet some undiscovered grand unified theory of physics that will describe all of those scales together. I think the mathematics that we need to discover, or we need to use or invent to actually write down the equations that will help us solve that, those big questions and those big sparks are the things that come first. After that, one then may start to look and say, well, having developed all of the skills that one might as a student or a pupil or as a researcher, you can then start to see where those can be applied. So, for example, you might be learning how to do galaxy scans and develop data analysis tools to work out how to figure out how a galaxy moves, and that might be then applicable to brain tomography scans. So actually being able to take the kinds of skills that students develop and young people develop when they're approaching some of the most fundamental questions that we have in science, and then applying those to other things, that's where the real excitement comes. So I'm an observational astrophysicist, and I use telescopes on the ground and in space. And in fact, it has been the space technology that has revolutionized our modern view of the universe. The atmosphere blocks most of the high-energy rays from distant objects. So, for example, very high-energy gamma rays and X-rays don't reach down to the ground, which is good, actually, because otherwise that would be a fairly dangerous environment for humans. Ultraviolet light, of course, gets through a little bit through the atmosphere. That's how one ends up sunburned if one doesn't, protect oneself in the sun. And so actually launching space satellites have actually enabled scientists to really address some big questions about the nature of the universe. And then combining that with ground-based telescope has really helped us to start to push the frontiers. And I think when we start to look at some of the advanced flight technology, so for example, the detection of gravitational waves, so ripples in space-time that are produced when massive objects like black holes collide together in the distant universe. It's a bit like throwing a pebble into a pond and then measuring those ripples. When those ripples travel across space-time and then come through our detectors on Earth, the ripples are so tiny, they're a fraction of the size of an atomic atom. We actually have to have incredibly sensitive technology to be able to detect those ripples. And the next generation of gravitational wave detectors, which actually will be launched into space, will require convoys of satellites flying very precisely in sequence to be able to act as big interferometers. So the arm of the detector will actually be two satellites. So I think the sort of in-flight and the human spaceflight and the general space technology that we're developing will go hand in hand with pushing new frontiers in fundamental science, right down to probing the nature of supermassive black holes colliding in the early universe. So wondering about when we'll go beyond our solar system and to other stellar systems, I think this is a really exciting prospect. I think it will need some imaginative and advanced solutions to propulsion. I suspect it won't be in my lifetime unless something very revolutionary happens. I think we should keep pushing to try to develop it. As I say, in my lifetime, I think it will be still in the realms of science fiction, but it's a very exciting prospect. Until then, we'll just have to harvest the light from nearby systems to figure out what's happening in nearby stars. So I think popular culture is a really exciting opportunity to connect our young people with science. And I think that, movies actually now, the sorts of graphics, the computer graphics that are required to produce the effects that one needs to be convincing in blockbuster movies. There's a lot of physics, there's lots of maths, there's lots of high-performance computing, actually, that goes into these movies. And so I think in terms of inspiring young people to go into that industry, before we even talk about whether that will inspire them to think about big physics or big science or big space science projects, that alone is already exciting. I think going beyond that, one interesting example is the movie Interstellar. Now, there's a professor in Carole Caltech, Kip Thorne, who actually was awarded the Nobel Prize for his role in discovering gravitational waves. And he, with colleagues, actually wrote a scientific paper in a very reputable science journal, and he worked with his colleagues in the movie company who were actually doing the effects and trying to put physics into the movie so that actually when the spacecraft got close to the black hole, without any spoiler alerts, that the physics were as accurate as they could be. And actually they worked together in a collaboration and wrote a research paper. So that's a really new way of doing fundamental research between two different sectors that would normally not work together. So I think the opportunities for popular culture to work with cutting-edge scientists, I think, is very exciting. What's my favourite space movie is possibly one of the most difficult questions I get asked. And in all honesty, I never answer it because there are so many great space movies out there, and I know that whichever one I pick, other people will agree or disagree with me, and I think that's the beauty of space movies. So I think it's great that space movies exist. My advice to anybody going to the movie theatre with physics friends, they will pick up on the physics and they will probably talk through the entire movie. So maybe go see it first with non-physicist friends and then take your physicist friends after.